Welcome back. Today, we join a builder raising a medieval shelter from the forest floor, relying entirely on raw materials and hand tools. The foundation phase demands a deeply anchored central support. Charring the base of the timber in an open fire is a crucial preservation technique. The fire hardens the wood fibers and creates a carbonized layer, preventing rot and fungal decay in the damp soil. Tamping the earth around the set pole locks it into maximum compression. With the primary load-bearing column set, the structural framework takes shape. A horizontal ridgepole transfers the future weight of the roof directly down into the vertical wattle walls. Balancing this geometry dictates the overall stability of the structure. Gravity handles most of the downward force, but lateral shifts must be restricted. Before modern fasteners, the forest itself provided the binding. Young saplings and flexible branches contain long, unbroken cellulose fibers. By stripping the outer bark and forcefully twisting the green wood, the builder fractures the internal grain without snapping it. This transforms a rigid stick into a pliable, high-tensile wide. As the braided wood dries in place, it will shrink and tighten, creating a permanent, rigid hold. The newly twisted cordage anchors the rafter to the main support. Lashing requires high tension across the joint to prevent the timber from slipping under load. Wrapping the fibers in overlapping figure-8 patterns distributes the stress evenly across the joint. Once tied off, this organic hardware becomes immensely strong. To shed heavy rain, the structure requires a steep, thickly thatched roof. Wild grass harvested at peak height provides a durable, water-resistant material. Using a rhythmic scythe swing, the builder processes massive volume efficiently. Bundling the stems tightly prevents them from tangling and aligns the stalks to channel water straight downward. Working from the eaves upward is fundamental to proper thatching. Each successive layer overlaps the one below it, creating a cascading surface that guides moisture away from the interior. Sharpened wooden spars pin the bundles deeply into the underlying framework, preventing wind uplift. Smoothing the exterior aligns the loose ends, breaking the surface tension of falling raindrops. The apex of a roundhouse roof is highly vulnerable to wind shear and water infiltration. To lock the top layer of thatch, the builder carves and lashes a rigid wooden cross. This heavy framework acts as a saddle. Secured with tight vine knots, it applies constant downward pressure over the central peak. Without this critical reinforcement, a single strong gust could peel the uppermost straw bundles back, exposing the core. A final, dense crown of straw caps the apex, directly beneath the wooden cross. Pressing this final layer flat ensures there are no vertical channels for water to travel down the center pole. Centering the cross clamps the entire roof system together, transferring the tension into the rafters below. The roof is now a unified, weatherproof canopy. With the canopy sealed, the woven wattle walls must be draft-proofed. Daubing forces a heavy mixture of clay and earth deep into the flexible lattice. The mud matrix hardens around the wood, creating a composite material. It acts as a massive thermal sink, absorbing daytime heat and blocking the wind. The interior carpentry requires precision, joining without nails. A mortise and tenon joint represents one of the oldest structural connections in woodworking. Carving a deep, square mortise demands careful chisel work to avoid splitting the grain. The adjoining tenon is hewn with an axe, reducing the thickness of the board until it perfectly matches the recess. A flat shoulder on the tenon prevents it from sinking too deeply, bearing the compressive load. When joined, the two timbers lock together tightly, preventing twisting or shear. To permanently secure the assembly, a hand-cranked auger bores a clean channel directly through the interlocking joint. A dry wooden peg, known as a treenail, is driven tightly into the void. Because the peg is extremely dry, it absorbs ambient moisture and expands slightly. This friction locks the timber forever. Sleeping directly on cold earth drains body heat rapidly. A raised wooden frame creates an insulating air gap between the sleeper and the ground. Thick layers of dry straw provide both cushioning and a trap for warm air. Covered in heavy woven wool, this internal furnishing elevates the structure from a crude shelter into a sustainable living space. High foot traffic quickly churns the earth outside the door into deep mud. Bedding heavy, flat stone into the soft ground distributes weight and creates a stable, clean threshold. Tamping them securely prevents settling, protecting the entrance from water pooling. Applying daub to the interior completes the thermal envelope. The addition of straw to the clay acts as a binding aggregate. It prevents the mud from cracking and spalling as the moisture evaporates. This smooth inner layer significantly brightens the dark interior by reflecting the ambient firelight. Processing raw green timber begins with splitting along the natural grain. Driving a wedge or heavy axe deep into the end, grain forces the wood fibers apart, utilizing the log's inherent weakness. Splitting green wood is highly efficient. The resulting plank is incredibly resilient because the continuous internal fibers remain uncut. An adze or small axe is then used to hew the split face perfectly flat. This meticulous squaring transforms raw lumber into precise architectural beams. Constructing a solid door requires specialized joinery to prevent the heavy panels from sagging over time. The builder marks exact geometric notches to accept cross-bracing. Removing waste material with short, controlled axe strikes leaves a clean channel for the brace. Squaring the bottom ensures maximum surface contact between the two intersecting timbers. The adze acts as a primitive plane, shaving high spots off the timber. This careful flattening ensures the individual planks lie perfectly flush against one another. Aligning the carved notches guarantees the cross braces will sit seamlessly across the entire width of the door. A tight fit eliminates drafts and creates a barrier against the elements. survival hinges on efficient cooking and heat management. A flexible wattle frame provides the temporary mold for a clay oven. Packing wet clay densely around the wooden ribs builds serious thermal mass. The thick mud walls will absorb extreme heat from an internal fire. They then radiate it back evenly, allowing for baking long after the flames die down. Pressing the clay deeply into the interwoven frame ensures the heavy walls will not slump under their own weight before curing. Smoothing the exterior surface is not just aesthetic. A uniform dome shape reflects heat evenly downward toward the cooking floor. Closing any microfractures in the damp clay is critical. A single crack can release trapped heat and severely drop the internal temperature. Working the surface with wet hands brings fine clay particles to the exterior. This creates a hard, burnished seal. The internal wooden frame will eventually burn away during the first firing, leaving only a hollow, self-supporting ceramic shell. With the infrastructure complete, the harvest can be processed. Kneading flour and water develops the gluten matrix, transforming a loose paste into an elastic dough. This physical manipulation aligns the proteins, allowing the bread to trap expanding gases during baking and rise properly. The resulting dense ball is resilient and ready for the extreme heat of the hearth. Igniting the hearth requires percussive force. Striking high-carbon iron against a sharp flint edge shears off microscopic shards of burning metal. When these hot sparks land in highly combustible processed fibers, an ember is born. Blowing gently forces oxygen into the core of the ember, rapidly raising its temperature. The heat quickly dries the surrounding grass until it reaches its flash point. Smoke turns to flame. A cast iron pot suspended over open flames conducts heat rapidly into the liquid. Adding raw meat and hearty root vegetables creates a dense, nutrient-rich broth. Simmering breaks down tough connective tissue in the meat, making the calories highly accessible. The sustained heat ensures safe consumption and deep flavor. The clay oven, preheated by a blazing internal fire, now operates on pure thermal radiation. Scoring the dough controls expansion, preventing the crust from rupturing randomly in the intense heat. Sealing the arched entrance with wet mud creates an airtight vault. This traps both the radiant heat and the moisture escaping from the dough. The trapped steam keeps the crust flexible long enough for the bread to rise to its full volume. the oven has done its job, yielding a fully baked loaf with a heavy crust. In the end, structure, landscape, and daily routine operate as one system. A deep hole in the forest floor has become a place that produces, protects, and sustains itself. Every hand-carved joint and mud-plastered wall serves this quiet moment of warmth,